This is my geometry course. Today we're going to cover circles, specifically tangents and arcs. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. We're going to start by giving an introduction to circles. You can see we have a circle here, and the center of the circle is E, and that's how we name circles, with the center. So this circle would be called circle E, and that's how we notate it, with a circle and a dot in the middle and the letter that the center is named. So let's talk about the basics of circles, and you can go ahead and get a picture with your phone or a screenshot so you can refer back to these as we do practice problems today. A chord is a segment that goes from one end of the circle to the other end, or one part of a circle to another part. There's a special chord called a diameter, which goes through the center of the circle, and if you take part of that, half of that diameter, and just take it away, you end up with a radius. And if you have a line that goes that hits two parts of the circle, 2 points on the circle, then that's called a secant line. And if you have a line that hits the circle at one place, then that's called a tangent. This is a tangent. It hits at one point on the circle. So we're going to go back over that stuff in more detail as we go along here, but let's learn our first theorem for the day. This is the Perpendicular Radius-Tangent Theorem. Other textbooks may give it a different name, probably a number, more than likely. This theorem says that if you have a line that is tangent to a circle, meaning it touches at one point, and we call that point the point of tangency, and you extend a radius so it goes out to that point of tangency, then the angle between the radius and the line is 90 degrees. So they're perpendicular. Now the converse of that is also true. If you have a line that connects with a radius, and the radius and the line are perpendicular, that proves that this line is tangent, meaning it touches only at that point of tangency. It's possible that if they're not 90 degrees, it's possible that that line would actually touch in two places if it was angled that way, or two places if it was angled that way. But if it's 90 degrees, that means it touches in only one place. It's kind of hard to see that. You kind of need a microscope. But let's try some practice problems. Again, go ahead and get screenshots of these so you can refer back to these as we do practice problems. If the line containing AC is tangent to circle B at C, find the following values. So we know that the line containing AC is tangent to circle B at that point C, and so what that means by that first theorem is that this angle must be 90 degrees. So if that angle is 90 degrees, then that means we have a right triangle, and we can easily find the measure of angle A. So we're going to have to use the triangle sum theorem. Measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180 degrees. The measure of angle A we don't know, we're looking for that. The measure of angle B we know is 46 degrees, and the measure of angle C is 90 degrees. And so if you do the math on that, we don't really have a lot of room to show the work, and I don't think it's really necessary to show the work. This is just basic algebra stuff. So you get 136, and then subtract that from 180, and you get 44 degrees. So you can use a calculator for that stuff if you want. And that is the answer, 44 degrees. And I'll put a divider. So Let's try number 2. AC, find AC if AB is root 61. So I'm going to take this triangle out, and they say AB is root 61, and we know this side is 5. They give us that here. And they want us to find this length here. So now we're dealing with lengths of triangles, and again, we know because the line containing AC is a tangent to circle B, we know that that angle there must be 90 degrees. This must be 90 degrees. So we're dealing with a 90 degree, or a right triangle. We want to find this side, which we can call B. I don't think we went over that a lot, but this side would be lowercase c because it's opposite uppercase C, the angle uppercase C. This side would be A because it's opposite the angle uppercase A, and so on and so forth. That's just a way of notating things. So we're going to use the Pythagorean theorem. And we don't have a lot of room, so I'm going to get rid of that. So a squared plus b squared equals c squared. And a would be 5 because that's opposite angle A, and b would be, we don't know, and c would be root 61 because that's opposite angle C. And again, we're given AB is root 61, so that would be side C because it's opposite C. I know that's kind of confusing. But so we get 25 plus b squared, and then when you square a square root, that's just the opposite of square rooting. See, this is square rooting. If you square it, that's the opposite of square root. So it just gets rid of the square root. And then if you do the math on that, we get b squared is equal to 36, and square root both sides, and we get plus or minus 6. But we don't write a minus sign because obviously a side of a triangle cannot be negative. But we want to say, we want to call it AC. So we'll just write AC is equal to 6. Now again, normally I would show all the work here. I would show the rooting both sides and so on and so forth, but we just don't have the room to do that. And by now you should know how those equations work without having to see every single step. So I'm not going to show all that. And you really don't have to show all the work. You just have to show the basic steps that you get that you use to get to that point. So now number 3, AB. We're looking for AB and measure of angle B. Now in this problem we need to use one of our special right triangles. We have a right triangle and two of the legs are equal. So that means it must be a 45-45-90 triangle. And that's one of the, like I said, that's one of the special triangles that we learned. So that means that this side must be omega root 2. So this side is omega root 2. Again, that's a special triangle. Now you may not remember that special triangle, but I just wrote it right there, right in front of you. So now you have it. So we know that omega is 3. So obviously AB would just be 3 times root 2, because again, omega is 3 in this case. What else do they want? Let's see, measure of angle B. So that's pretty easy because we know that those are 45 degree angles, so measure of angle B must be 45 degrees, and there you go. Again, I'm going to give you one more chance to get a screenshot of these if you haven't done that already, and you might want to, well, I guess you already got a screenshot there. So now try number 4, and when you come back, we'll do it together. All right, we're back. So we know that this is a 90 degree angle here because the line containing CB is tangent, or excuse me, the line containing CA is tangent to the circle. So we're looking for CB. So I'll just pull that triangle out. We have 12 and we have 15. Whoops, that's the wrong side, sorry. This side is 12, and we're looking for this side here. So you can see we're just dealing with the Pythagorean theorem. So a squared plus b squared is equal to c squared. And b would be 12. And a, we don't know. And c is 15. So now we get 144 is equal to 225. Or 144 plus a squared is equal to 225. Subtract 144 from both sides. And we get 81. And square root both sides, and we get a is equal to plus or minus 9. But of course, a side of a triangle cannot be negative. And they want CB, so we'll just change that to CB. It's the same thing as lowercase a, and that equals 9. Now there are units, so you have to write 9 millimeters. If you don't write 9 millimeters, then you would have points taken off on that. Let me put a divider there. So if you got that answer, good job. Go ahead and try number 5, and when you come back, we'll do it together. All right, we're back. Measure of angle B. We know that this angle is 90 because, again, we know that the line containing CA is tangent to the circle at C, where it's connected to the radius B. And so we're going to use the triangle sum theorem. I don't have to write out the theorem, but we'll just say angle C plus angle A plus the measure of angle B. I should be saying measures of the angles, technically, is 180. And so you can use your calculator if you want. Just do all the math on that. 90 plus 42 is 132. And subtract that from 180. And you get 48 degrees. So the measure of angle B is 48 degrees. So if you got that answer, good job. We'll rectangle that. And so for number 6, I want you to be aware that we're dealing with a special triangle here. So I'm going to draw this special triangle for you. If you don't remember. So if this side is W, then this side would be W root 3, and this side would be 2 times W if you're dealing with a 30, 60, 90 triangle. So that's one of the special triangles. So you're going to use this relation in the next problem. So try number 6, and when you come back, we'll do it together. All right, we're back. Now, again, we know that this is 90. And we know that angle angle C is 60 because they tell us that in the problem. So that means, based on the triangle sum theorem, that means that this angle must be 30, and we see we're dealing with that special triangle, that 30, 60, 90 triangle. So we know that these are the relations between each side. So we know that this side is 5 root 3, so that means W is 5. So obviously, well, let's do the easy part, or the first part. Measure of angle B, we already figured that out. That's 30 degrees. There's not really a lot of work you have to show for that. And AC, if this is 5 root 3, if this is W root 3, then this is W. So W is 5, so AC would just be 5. Again, because this is a special triangle, we can see very quickly what these values are. And AB, that must be 2 times W. W is 5, so AB is 2 times W, which is 10. So if you got those answers, good job. Now, if you forgot your special triangle, that's okay. But, now you know. Again, there's 2 special triangles we learned, the 45, 45, 90 and the 30, 60, 90, and you have to memorize those relations. If you didn't memorize those, that's okay, but for the test, you might have to have those. All right, so if you got those answers, good job. On to the next problems. If BC is a radius is the line containing AC tangent to circle B? So we know that this is a radius. We know that the line containing AC is tangent. So you can see by this picture that it's kind of just assumed that that AC and BC are meeting at the same point. That's kind of important for these problems, as it was for the previous problems. We have all the sides. You see, we have this side is 12, and we have this side is 5. And we also have this side, which is 13. It tells us up here that AB is 13. So we have all the sides of this triangle. And what we're going to do is we're going to prove that this radius and this side of the triangle, which they both touch at point C, we're going to prove that the angle between them is 90. And if it is 90, that's going to prove that, again, given that these touch at that same point, if it is 90, that's going to prove that AC, or that the line containing AC, is tangent, meaning it only touches one place. If it were not tangent, then the line might touch actually two places if it were going that way, or two places if it were going that way. So it'd be a secant line, not a tangent line. But in order to do this, we're going to have to refer back to this theorem here. We know the Pythagorean theorem, but the converse of the Pythagorean theorem is also true. So the Pythagorean theorem says that if you have a right triangle, then the square of the hypotenuse is equal to the sum of the squares of the legs. But the converse of the Pythagorean theorem says that if you have if the square of the biggest side of a triangle is equal to the sum of the squares of the other sides, then that proves that it's a right triangle, meaning one of the angles is 90 degrees. So we're going to use that in these problems. So we're going to start by just plugging in those numbers, and we're going to use, again, this relation. We don't know if this relation is true yet, but we're going to plug it in and see if it's true. And so I should probably write maybe a question mark there rather than an equal sign, because we don't really know if it's true. A is going to be 12, B is going to be 5, and C is going to be 13. So we get 144 plus 25 is equal to 169. You can use your calculator for that if you want. And we end up with 169 is equal to 169. So it is true. So it was question marks, and then we see, yes, it does work. So the answer is yes, the line containing AC is tangent to B at C. And it says to justify your answer. That's pretty much what this is here, the justification. So this might seem a little complicated, but it's really easy. You're just trying to plug in those numbers to see if the Pythagorean relation works. So I'm going to write it out again. And A is going to be root 2. B is root 3. And C is 2.5. So when you square a root, remember, it just gets rid of the root. So you have 2 plus 3 is possibly equal to whatever 2.5 squared is, and that just happens to be 6.25. Again, you can use your calculator for that if you need to. So we have 5 is not equal to 6.25. So the answer is no. The line containing AC is not tangent to circle B at C. All right, number 9. Same situation. We're going to see if the Pythagorean theorem relation works. So A is 2, B is 1, and C is root 5. And then we have 4 plus 1 is possibly equal to 5. And we get 5 is definitely equal to 5. So the answer is yes. The line containing CA is tangent to circle B. And in these problems, it's very important that CB and CA meet at the same point, but you can kind of see that just looking at these problems. So you might want to take a screenshot of all this work that we did. Now it's time for you to try some of those problems. Try number 10, and when you come back, we'll do it together. All right, we're back. So again, we're going to see if this Pythagorean relation works. We have 1 squared plus root 3 squared is possibly equal to c squared. And we have 4 is definitely not equal to 9. So the answer is no on that one. So if you said no, good job. All right, on to number 11. Go ahead and try number 11. When you come back, we'll do it together. All right, we're back. A is 15, B is 8, and C is 16. So these are kind of big numbers, so you can use your calculator if you need to. 16 times 16 is 256. And if we add 225 to 64, we get 289. By the way, I should be putting question marks here, I guess. And you can see that that's definitely not equal to 256. So the answer is no. The line containing AC is not tangent to circle B at C. So if you got that answer, good job. All right, so try number 12, and when you come back, we'll do it together. All right, we're back. A is 1, B is also 1, and C is root 2. 1 squared is 1, 1 squared is 1, root 2 squared is 2, and we have 2 is definitely equal to 2, so we can say yes, the line containing AC is tangent to B at point C. So if you got those answers, good job. Those are just some typical problems that you'll see with this with these concepts. So now we're going to learn another tangent theorem. This is called the tangents from a common point theorem. So if you have two tangents that are drawn from a common point, and you know that they're tangent to the circle, they're both tangent, then that means that the length of this segment is the same length as of the segment BP. So it's a pretty easy theorem there. You can take a screenshot if you want. So it says if C and D are points of tangency, find the following values. So if these are points of tangency and the segments are coming from the same point, that means that this length is equal to this length, or the segments are congruent. So we can say 5x minus 4 is equal to 2x plus 8, and we just do the math on that, and we end up with x is equal to 4. Now that's not the answer. They want QD. So QD is equal to 2 times the x value, which we just found is 4, plus 8. So QD is equal to 16. So pretty simple stuff. Same thing with this one. We know that this segment length is equal to this segment length. So x squared is equal to 16. We square root both sides, and we get x is equal to plus or minus 4. Now this is going to be something that is a little confusing for students. Remember how we said that a length cannot be negative? Well, that is true. A length cannot be negative. But if you plug in positive 4 or negative 4 into this expression, you're going to get a positive length. So both positive 4 and negative 4 are solutions. They're possible values for x. I know that seems kind of weird. If you plug in a negative x value here and you end up with a negative length, like if we got negative 16, then that wouldn't work. That would not be a solution. But because you plug in a negative and it turns it to a positive and you still have a positive length, a negative value can still be a solution. All right, so as you can see, those are pretty easy. Let's go ahead and have you try some problems. So try number 15, and when you come back, we'll do it together. All right, we're back. 15y is equal to 7 minus 10y, and we're just going to add 10y to both sides. Divide both sides by 25, and you get 7 over 25, and that's what we're looking for, 7 over 25. Now, is that a weird number? Yes, it is. Does it matter? Not really. That's just the solution. So if you got that answer, good job. Go ahead and try number 16, and when you come back, we'll do it together. All right, we're back. So we know that those lengths are equal. Add 3x to both sides, we get 8x. Subtract 20 from both sides, we get negative 24. Divide both sides by 8, and we get negative 3. Now, again, it seems like there's a problem here because we can't have a negative length. And that is true, we cannot have a negative length. But what you'll find is that when you plug it in, you'll see that it's not going to create a negative length. So we're looking for dp ultimately. And if we plug that in, we get 5. So it's completely fine for x to be a negative, but that's not even our solution. Our solution is dp, that's 5. We're looking for dp up here. Whereas in the previous problem, we were just looking for one of the variables in the expression. So if you got 5, good job. All right, moving along here. Now we're going to combine two of those theorems, those tangent theorems that we used. We learned a theorem that says that if you have a tangent segment that meets the end point of a radius at that point of tangency, then that means the angle between them is 90 degrees. So we know that these angles are 90 degrees. And we also know that we just learned that theorem that says that, if you have two segments coming from a common point, then these lengths are equal. So we know those two lengths are equal. And we also know that these are both radii. So that means that these, obviously, if they're both radii of the same circle, then those must be equal length. So what you can see here is we actually have a kite. Remember, a kite is a quadrilateral with two pairs of congruent sides. And so we know that this is a kite because of just the definition of radii, and we know from this theorem that these are congruent, and we also know that these are 90-degree angles. But this theorem just tells us that if you have two different tangent segments that are drawn from a common point outside the circle, and two radii of the circle are drawn to the points of tangency, then the resulting quadrilateral is a kite. So that's the Kite Formed by Tangents and Radii Theorem. So you might want to take a screenshot of that. But again, in these problems, because of that one theorem, we know that these are also 90-degree angles. That's going to help us. If the segments below are radii and tangents, find the following values. We know that this must be a kite, and we know that these angles must be 90. Now, you may recall the polygon interior angles theorem. I think that's what I called it. That says that if you want to find the sum of all the interior angles in a polygon, then you take 180 and you multiply it by the number of sides of the polygon minus 2. So in this case, we have 4 sides as a quadrilateral, and 180 times 2 would just be 360. So you may have remembered that. The angles, the interior angles of a quadrilateral, they always add up to 360. So we're going to use that theorem. So measure of angle A plus the measure of angle B plus the measure of angle C plus the measure of angle D has to be 360 degrees. Now, the measure of angle A we know is 39 degrees. Measure of angle B we don't know. That's what we're looking for. And the measure of angle C is 90 degrees. Remember, that's one of our theorems. Measure of angle D is 90 degrees. And we get 360. So we can just do all the math on this. Add up those 90-degree angles. You get 180. And then add 39 to that, and you get 219. And then subtract that from 316, and you get 141 degrees. So the measure of angle B is 141 degrees. That's one of our answers. And the other thing that we need is CA. CA is really easy. In fact, we probably should have done that first. This is a kite, so we know this side is 37, so obviously this side must be 37. And be sure to write the units. So CA is 37 degrees. All right, so it's pretty easy there. Let's try another one of those problems. We're looking for a measure of angle B and also CA. Now let's do the easy part first this time. So CA, we know what that's going to be because CA is just a radius. All the radii in the same circle are always equal. So if this radius here is 8 inches, then we know CA must be 8 inches also. Just be sure to write the units there. And the measure of angle B, we're going to use the same logic we used before. So the measure of angle B plus the measure of angle C plus the measure of angle D plus the measure of angle A, which we know is 100, must be equal to 360. So I'm going to make some more room here. Add all those up, and we get 360. And let's see, that would be, looks like it would be 80 degrees. If you do the math on that, measure of angle B is 80 degrees. And I think that's it for that problem. Let's try a couple more of these before you try one on your own. The measure of angle, well actually let's do the easy part first. So CE is equal to, if this side is 27, then obviously CE must be 27 too, because this is a kite. 27 centimeters, be sure to write your units. Now in this problem, we are looking for, you're going to have to draw the diagonal. We're looking for DAE. DAE is actually this angle here. So now this is a kite, so all the theorems that apply to kites apply to this quadrilateral. And recall that if you draw this diagonal, that cuts this angle in half and it cuts this angle in half. So that's what we're looking for. We're looking for the measure of this angle, which is half of the measure of angle A. So first we're going to find the measure of angle A. So the measure of angle D plus the measure of angle C plus the measure of angle E plus the measure of angle A is equal to 360. And if you do the math on that, we come up with 144 degrees. Now that's not the answer. We want the measure of angle DAE. So the measure of angle DAE is half of 144. And that would be 72. So we get 72 degrees. All right, so let's try one more of these problems before you try one on your own. Now it says we want, let's do the easy part first. So the measure of angle C, that's pretty easy. That's just going to be 90 degrees. And QS, we're looking for this length here, QS. Now, I'm going to pull that triangle out, the upper triangle. And they tell us that this side is 3. And again, I'm pulling out this triangle here. So that side is 3. Now, we don't know this side or this side. We're looking for both those sides. But again, we know that this radius here is 1. So remember, all radii in the same circle are the same length. So this length must be 1. And now we can use the Pythagorean theorem because we know this is a 90-degree angle. Because again, we're dealing with a tangent to a radius. So that means that 3 squared, and let me just go ahead and write the Pythagorean. These letters are not necessarily going to correspond. But as long as you understand, we're using the Pythagorean theorem. And we have 3 squared plus 1 squared is equal to c squared. And that would be 9 plus 1 is 10. So we have 10 is equal to c squared. And just square root both sides, and we have c is equal to root 10. But we're going to change that to QS. That's really what we're looking for. QS is equal to root 10. It would be plus or minus root 10, but again, you can't have a negative side. All right, so now it's time for you to try. You can take screenshots of these problems we did down here if you want, along with that theorem. And also, I'm going to go ahead and leave this in those 2 problems in the window we just did. So try number 21, and when you come back, we'll do it together. All right, we're back. DL, that's pretty easy. That's just the length of a radius, so that's 10 meters. So if you got 10 meters, good job. Measure of angle O, we have to use the polygon interior angles theorem. So angle D plus angle C plus angle L plus the measure of angle O, and again I should be saying measures of the angles, is 360. So do all the math on that, and we should get 71 degrees. So measure of angle O is 71 degrees. So if you got those answers, good job. Go ahead and try number 22. When you come back, we'll do it together. All right, we're back. BD, that would be equal to 6 feet because this is a quadrilateral. And we just use the same polygon interior angles theorem to find the measure of angle E. So the measure of angle D plus the measure of angle C plus the measure of angle B plus the measure of angle E is equal to 360. Do all the math on that, and we get the measure of angle E is equal to 130 degrees. So if you got those answers, good job. All right, on to 23. Go ahead and try number 23. Just be aware that we are looking for DLG, so we're looking for this angle here. So go ahead and try 23. When you come back, we'll do it together. All right, we're back. Let's do the easy part first. CG. That is a radius, and so that's 9 meters, same length as the other radius. Measure of angle DLG, that's going to be really easy because remember our theorems relating to kites, they apply here because this is a kite. So if you draw this diagonal, it just cuts the angles in half. So that would just be 32 divided by 2. And so the measure of angle DLG is equal to 16. and it should be 16 degrees. So we got those answers. Good job. Be sure to write meters, 9 meters. You need your units there. All right, 24, go ahead and try number 24, and when you come back, we'll do it together. All right, we're back. So we know LM is root 6. So I'm just taking this bottom triangle out. If I draw the diagonal, I'm taking this triangle out and drawing it here. And we know that this side is 2, and we're looking for dm. dm is a radius, so if we find the length of MC, which is going to be this, then that'll be the length of dm. So we know this is a right triangle, because again, that's a tangent. So a squared plus b squared is equal to c squared. The letters don't really correspond, but we have 2 squared plus mc squared is equal to root 6 squared. And so we get 6 is equal to mc squared plus 4. Subtract 4, we get mc squared is 2. Square root both sides, and we get mc is equal to plus or minus root 2. But in this case, we can't have a negative length. So mc is equal to root 2. Whoops, that's not the answer. See, that's what happens when you jump forward. MC is not the answer. We need dm. But it just turns out that dm is equal to mc. So dm is root 2. So if you got that answer, good job. All right, moving along here, now we're going to learn about arcs. We're first going to learn central angle. A central angle is an angle whose vertex is on the center of a circle. So this is central angle here. You can see the vertex of that angle is the center of the circle, and the sides of the angle are radii. And arc measure is a value, it's going to be a little weird to consider arc measure. Now, this is an example of an arc. It's just part of a circle. And this is another example of an arc. And arc measure, in this case, the arc measure would be 85 degrees for this arc. Arc measure it's just a value that indicates the size of a part of a circle in relation to the rest of the circle. Now, it's important to understand that 85 degrees is not the actual length of the arc. Arc measure is just a number that gives you an idea of how big the arc is compared to the whole circle. Now, it's also important to understand, and by the way, you can take screenshots of these. That's probably a good idea. Take a picture with your phone or get a screenshot for your files. It's important to understand that the central angle is equal to the corresponding arc measure. And that's just a definition. And I know that seems kind of weird. That's basically what this statement says here. But we're gonna see why why it's defined that way as we go along in further classes. But as you can see, this arc measure here is 85 degrees, and the arc measure here is 275 degrees. The arc measure is defined to be 360 for the complete circle. So, we use degrees for arc measure in the same way that we'd use degrees for rotation. But arc is not really a rotation. We're just using degrees, again, to show a relation between the size of the arc and the whole circle. Also, I should mention that this here is called a minor arc, and this is a major arc. Minor arcs are less than 180 degrees, and major arcs are greater than 180 degrees. Major arcs always are notated with 3 letters. So in order to write the major arc here, the measure of arc ADB, I had to have a 3rd letter written here. And that's just so that you don't confuse the minor arcs with the major arcs. And an arc, this is obviously arc measure here, but arc is always notated with an arc here. So you write the arc over the letters, and if you have just 2 letters, you'd write the arc over the 2 letters like so. So it's important to understand this is the measure of the angle, and this is the measure of the arc. So when you have an angle, obviously you'd have that angle symbol. With arc, you'd have the arc symbol. It's also important to understand that arc length is not the same thing as arc measure. If you want arc length, that would be the actual length of this arc, and that depends on how big the circle is. But arc measure does not depend on how big the circle is. You can have a very, very large circle or a very, very small circle, and the arc measure here would be the same as the arc measure here, even though one arc is bigger than another arc. Let's say I have let's say it's about a, 90-degree arc. If you do a 90-degree arc here, you can see the arc itself the arc length is very different. But the arc measure is actually the same. They're both 90-degree arcs, roughly. Now, technically, this arc measure is different because we're talking about different circles, but the actual number itself, the arc measure, is the same, 90 degrees in that case. So again, just be aware, arc length, we're going to learn how to find arc length later on in this class. It's not the same thing as arc measure. So the arc measure of this arc would be 85 degrees, but the arc length, that's not measured in degrees, that's an actual distance. So you would have to find that using something different. So this is just what we were talking about before, minor arc and major arc. A semicircle is an arc with 180 degrees. And we learned the segment addition postulate, which says that if you have 2 segments next to each other in a straight line, then then AB plus BC is equal to AC. That's pretty simple. We had the angle addition postulate, which says that if you have 2 angles with the same vertex and sharing a common side, then the overall angle is equal to the sum of the individual angles. And now we learn the arc addition postulate. That just means that AB plus BC is equal to AC. It's pretty simple. So again, if you didn't get screenshots of those, go ahead and get screenshots. And now we're going to do some practice problems. If K is the centers of the following circles, find the values below. So they give us the central angle here. This is called the central angle, is 35 degrees, and they want us to find the measure of arc AB. So the measure of arc AB is just exactly the same as the central angle, because that's the corresponding arc of that central angle. So the measure of arc AB is just going to be equal to 35 degrees, no big deal. Now they want us to find the measure of arc ACB. The measure of arc ACB, that's just going to be 360 minus 35, because a whole arc, the arc of the entire circle, is 360 degrees. So the measure of arc ACB is equal to 325 degrees. Number 26, now we want the measure of angle DKE. So this is an actual angle. DKE is going to be this angle here. Now, we can think of this arc measure as an angle, the central angle, or we can think of this central angle as an arc. It doesn't really matter, it's all the same thing. I'm just going to make this, this angle we know is 120 because the central angle is equal to the corresponding arc. So if we bring that out, we have 90 degrees, we have 120, And then we're just looking for this angle. So we know that these angles all make a full rotation. So we just take 360 and we subtract 90 and then subtract 120, and that should be equal to the measure of angle DKE. So we get, looks like it's going to be 150. So measure of angle DKE is equal to 150. That's the first part of the problem, and we need the measure of arc DFE. So just be aware that these angles and these arcs, they're different things, even though they sometimes end up being defined to be the same magnitude. So measure of arc DFE, that's the arc from here all the way to here. So for that, we just add the arc measures based on the arc addition postulate. Again, this is a central angle, but we can consider the corresponding arc to be the same. So it's 90 degrees. So 120 plus 90 is 210 degrees. So the measure of arc DFE is 210 degrees. So let's try a couple more of these problems before you try one on your own. The measure of angle HKI and the measure of arc HJI. So HKI, that's this angle here, but that's a straight angle, because we know that HJ is a diameter. They told us that, and we can kind of see that it's a diameter. So the measure of angle HKI, whoops, that's actually not the right angle. I'm sorry. We're looking for this angle, HKI. But because this is a diameter, we know that this whole angle here is 180 degrees, so we can just take 180 and subtract 118. And so the measure of angle HKI is equal to 62 degrees. And the measure of arc HJI, that's this arc from here all the way to here. So there's a lot of different ways we can do that. We could just take 360 and subtract 118, and we know this is 180 because it's a semicircle. Or we can just take 180 and add 118. So then we get 280, 298, it looks like, 298 degrees. All right, let's do one more of these problems before you try one on your own. Now in this case we have two diameters. We have LN, that's a diameter, and we also have MO, and that's going to be important information. So first we're looking for arc, or the measure of arc ONM. ONM, that's this arc here, but because we know MO is a diameter, that's going to be pretty easy. So the measure of arc ONM, that's just going to be equal to 180 degrees, because that's just a semicircle, because we know MO is a diameter. And now we need the measure of angle LKQ. So that's this angle here. And we know that this is 180 degrees because that's a diameter. And we know that this angle is 70. And this arc is 25, which means the corresponding central angle is 25. So if you take that out, we have 25 and 70. And obviously to find this angle, you're just going to subtract 25 and 70 from 180 because, again, this is a straight line. There's multiple ways to do this. So the measure of angle LKQ is equal to 180 minus 70 minus 25. And if you do the math on that, we get 85 degrees. All right, now it's time for you to try. You can take screenshots of those problems that we just did, or I'll just leave them in the window for you. So go ahead and try number 29, and when you come back, we'll do it together. All right, we're back. Measure of angle AKB. So we want the central angle here. But the central angle, that's just, the central angle is just the same measure as the measure of the corresponding arc. So the measure of angle AKB is equal to 80 degrees. So if you got that answer, good job. Now we need the measure of arc BCA. So that's this arc here from B to A. So we know the whole thing is the arc of the whole circle, as every circle, is just 360 degrees. So we just take 360 and subtract 80 degrees. And we get 280 degrees. So if you got those answers, good job. Go ahead and try number 30, and when you come back, we'll do it together. All right, we're back. Measure of angle DKE. Now we're given the arc, the corresponding arc, and we're asked for the central angle. So the central angle is just 89 degrees. It's the same thing as the corresponding arc. And the measure of arc DF, that's this arc here. And that arc is going to be there's a lot of different ways to find this. You can consider all these angles to be arcs, or you consider all of them to be central angles. I'm just going to consider them to be central angles. So we know this central angle is 89. Now we know this is 160. So we just subtract those from 360, the total arc, or the total rotation, to get the measure of DF. So DF is equal to 360 minus 160 minus 89. So that gives us, you can use your calculator for that if you want to. 360 minus 160 minus 89 is 111 degrees. And we know that this angle is 111, which means the corresponding arc is 111. But again, you can consider this to be a 160 degree arc and just think of it in terms of arcs if you want. So if you got those answers, good job. On to number 31. Go ahead and try 31, and when you come back, we'll do it together. All right, we're back. Measure of arc IHJ. IHJ, so that's from here all the way to here. Probably the easiest way to do this, like I said, there's more than one way to do this. But probably the easiest way is just to take 360, the total arc, and subtract 81 degrees. And you can use a calculator for that if you need to. So 360 minus 81 is 279. So 279 degrees. And we need the measure of angle HKI. HKI, probably the easiest way is to do 180 minus 81, because this is a straight line, so obviously the total arc measure here would be 180 degrees. So if you do that, we get 99 degrees. So if you got those answers, good job. All right, go ahead and try number 32, and when you come back, we'll do it together. All right, we're back. Measure of angle MKN. So we have two diameters. We need to keep that in mind. There's a lot of different ways to do this. The easiest way that I can think to do this is consider the fact that we have vertical angles. This angle here is equal to this angle because the vertical angles theorem. That may be a little hard to see. Again, this angle is equal to this angle because you have two line segments crossing each other. And so that means that this angle plus this angle must be 115 degrees. So that pretty much gives us the answer. It's just going to be 115 degrees. So that was pretty easy if you know the vertical angles theorem, or opposite angles theorem. We have two names for that theorem, remember. So now we need the measure of arc LMQ. LMQ, that would be from here to here. We don't know what this angle is. If we knew that angle, then we could just add it to 40 degrees and we'd have LMQ. But we know that this arc is 180 degrees all the way around. And we know that this arc is 115, so I'm going to use that. In fact, actually, we could use this arc also. So I'm just going to do that. I'm going to use this arc. We know that those arcs must add up to 180 degrees because this is a straight line segment. It's a diameter. So I'm just going to subtract 115 from 180, and that gives us this arc here. So LM, the measure of LM, is equal to 180 minus 115, which equals 65 degrees. And then the measure of LMQ is just 65 degrees plus 40 degrees, which equals 105 degrees. So the measure of LMQ is equal to 105 degrees. All right, now we're going to move on to arc length. We talked about arc measure quite a bit, and central angles and so on and so forth. Now we're going to talk about arc length. This is the actual length of an arc. So that depends on how big the circle is. So that's the red part. We're going to find that actual length. Now, in order to do this, we have to review circumference. Now, circumference is the length of an entire the perimeter of the entire circle. So if you want to find the distance around the entire circle, that's a complete arc, a 360-degree arc. If you want to find the length, you use circumference, or that's called circumference. And the formula is 2 pi r. That means you take 2, and then you multiply it by pi, and then you multiply that by the radius of the circle. You can also take the 2 and r and just multiply them together, and that gives you diameter. And then you multiply that by pi. So that's another way to write it. So that gives you the total arc of the whole circle. So we learned that in previous classes. And by the way, in this class, you're going to use pi in your calculator. You need to use that pi button in your calculator. A lot of students are told to round it off to 3.14. That's okay for pi. But in this class, we're not going to use 3.14. You're going to need your calculator for that. If you don't have a calculator, then you can just use 3.14, but just be aware that your answer may be a tiny bit off. So now we're going to find arc length. We don't want the length of of the entire circle. We just want the length of a small part of it. So what we're going to do is we're going to take the total circumference and we're going to multiply it by some fraction, because if you multiply by a fraction that's less than 1, then it's going to make that number smaller. Obviously, if this is the arc length of the whole circle, if you multiply it by a fraction, you're going to make it smaller. So this angle here is going to be the central angle, the corresponding central angle of that arc. And you just divide it by 360, and that's your fraction that you're going to multiply to get the actual arc length. It's very easy. So if you didn't understand all that, that's okay. You might want to get a screenshot of all that. We're going to do some practice problems, and you're going to see exactly how to use this formula. So, and by the way, arc length is notated with this cursive L here. So whenever you see this, it means find the actual length of the arc AB. It's very important. So you see this cursive here, we're looking for the arc length of AB. So arc length of AB is equal to, we're going to take the central angle, divide it by 360, and you're going to do this a lot of times, so you're going to memorize this formula pretty quickly. And then we multiply that by 2 pi, and you can use parentheses on both of these if you want, and times 8. I kind of have a lot of parentheses happening here, but when it comes to parentheses, usually the more the better. So then we get the length, arc length of AB, and we just have to crunch those numbers. So in your calculator, you can just take 50 and then divide it by 360 and push equals. Then you push times 2 equals, and then times the pi button. And if you're using a phone, the calculator on your phone, you might have to switch it to landscape mode so you can have the pi button there. So times pi equals, and then times 8 equals. And that gives us, if we round to the nearest hundredth, it tells us here round to the nearest hundredth. So that gives us 6.98 centimeters. And we cannot write equal to, we have to write approximately equal to because we're rounding off. And that is the answer, that's the arc length. So you can see that's pretty easy. So let's try another one of these. We want the arc length of DE. So the arc length is equal to, and now we have 90 degrees, that's the central angle, so we take 90, divide it by 360, and then we multiply. Again, you can use parentheses on one of these expressions or both, it doesn't really matter. Depends on the context. So then 2 pi times the radius, which is 5. So then we just get the calculator out, and 90 divided by 360 equals, and then times 2 equals, and then times pi equals, and then times 5 equals. So 7.85. And that is inches. So as you can see, this stuff is pretty easy. Most of the stuff we're doing in this class is really fairly easy. So now we're looking for the arc, the arc length GJH. And that is going to be, now this is something where you really have to be careful here, because they're trying to fool you. See, they're looking for this arc length, but we can't find that arc length unless we have the corresponding central angle. We don't have it. We only have this one. So obviously we would just take 180, and I don't have enough room here, so I'm just going to do it vertically. 360. 360 minus 123. This is how we used to do it in arithmetic. And we get 237. So that's the actual central angle we're going to use. 237 over 360 times 2 times pi times the radius, which just happens to be 1. So let me move this over. And so again, we just get out our calculator. So 237 divided by 360 equals times 2 equals times pi equals times 1 equals. Of course, we don't really have to multiply by 1 because that doesn't really change anything. So then we get 4.14, and that is feet. Be sure to put your units here. If you don't put your units, then it's not gonna. You're not going to get an answer that makes any sense. Whoops, that should be a J, not an I. All right, so on to the next problem. Let's try one more of these before you try one on your own. We're looking for the arc length of LM, the length of arc LM. So that's the length of this arc here. Now again, we're not looking for arc measure, we're looking for arc length. So first thing we have to do is find the central angle. Remember, we have to use the central angle to find the arc length. Well, we know this is 180 degrees. So the measure of the central angle we're looking for, LKM, is equal to 180 minus 59. So the measure of angle LKM is equal to, you can do that in your calculator, 180 minus 59 is equal to 121. Whoops, that's not the answer though. So this angle here, LKM, is 121 degrees. So now we can find the arc length. So the length of LM, arc LM, is equal to 121 over 360 times 2 pi times the radius. Now, be very careful here. We want the radius. If we're going to use 2 pi r, we need the radius. 6 meters is not the radius. That's the diameter. So you have to take that and divide it by 2. So 6 divided by 2. I'm just going to show that just to make sure you see what I'm doing there. So 6 divided by 2 is obviously 3. The radius is obviously 3. So 121 divided by 360 equals, then times 2 equals, then times pi equals, then times 3, because 6 over 2 is 3. So 6.34 if you round to the nearest hundredth. Again, we're in all these problems, we're rounding to the nearest hundredth. And if you use 3.14 for pi, you're not going to get exactly the same answer, so just be aware of that. All right, so now it's time for you to try. If you didn't get screenshots of all this stuff and the formula that we're using, go ahead and do that now. And like I said, you can actually write diameter times pi here. That also works, but usually you see it as 2 pi r, so I'm just writing as 2 pi r. All right, so try number 37, and when you come back, we'll do it together. All right, we're back. The length of arc AB is equal to 130 over 360 times 2 pi times r, which is 10 millimeters. And as you saw in the previous problems, these are just basically calculator problems. 130 divided by 360, then times that by 2, and then times it by pi, and make sure you use the pi button in your calculator, equals, and then times 10 equals 22.69. That was kind of a weird one to round, so be aware the rounding is a little weird on that. So the length of arc AB is equal to 22.69 millimeters. Be sure to write your units. So on my calculator I got 22.689, but if you look at 9, you round up. I guess it's not really that big of a deal. It's just a standard rounding problem. Sometimes when you see 9s, it makes things complicated. All right, so if you got that answer, good job. If you didn't, that's okay. Just figure out what you did wrong. And why don't you go and try number 38, and when you come back, we'll do it together. All right, we're back. So the length, and whoops, I forgot to put an arc there. The length of arc JHI is equal to, so JHI is this arc here, so we need the central angle. Well, obviously the central angle is just 180. It's a semicircle. So it's going to be 180 over 360 times 2 pi times the radius. Now, this is where some students may make a mistake here. The radius is not 17 feet. The radius is half of 17. If you divide that by 2, you get 8.5. So I guess I'll just write that just so you're sure where I got that, 17 over 2. And so now we just have to crunch the numbers. Let me try to fit this in here. All right, so we can get our calculator. 180 divided by 360 is obviously just 1/2. Times that by 2 equals, times it by pi equals, and then times, what was that, 8.5, because 17 divided by 2 is 8.5, so equals, we get 26.7. 26.7, and that would be feet. I'm going to move that over later. So we have the length of arc JHI is approximately equal to 26.7 feet. So if you got that answer, good job. All right, on to number 38, or excuse me, 39. Go ahead and try number 39. I'm going to leave those in the window, and when you come back, we'll do it together. All right, we're back. The arc length of DJE, or DGE, is equal to, let's see here, DGE, so that's going to be this arc here, but we can't find that arc length because we don't have this central angle. First we have to find that central angle. So obviously the measure of that angle is just going to be equal to the measure of arc DGE, which is 360 minus 43 degrees, which equals 317 degrees. And so now we have our central angle, 317 over 360 times 2 pi times the diameter, which is 9. Excuse me, the radius, which is 9. Crunch the numbers. 317 divided by 360 times 2, then times pi, the pi button, equals, and times 9 equals 49.79. And be sure that you're entering this properly in your calculator, because if you don't do it in the correct, if you don't push those buttons in the correct order, you're going to have a lot of problems. 49.79 inches. So if you got that answer, good job. If you didn't get that answer, most likely you're not plugging the numbers in correctly into your calculator. Calculators are very fidgety when it comes to the order that you plug those numbers in. So if you're having problems, that's probably going to be the cause of your problem. You want to write equals after every time you multiply a number or divide a number. So go ahead and try number 40, and when you come back, we'll do it together. All right, we're back. We're looking for this arc length, and we can't find that arc length because we don't have the corresponding central angle. But we know this is a semicircle, which is 180 degrees. So the measure of angle LKM is equal to 180 minus 60, obviously. So that would be 120 degrees. So now we have the angle, the central angle that we need. So the length of arc LM is equal to 120 over 360 times 2 pi times the radius. Now we don't have the radius. We only have the diameter. So we have to take the diameter, divide by 2, and then we just crunch those numbers. 120 divided by 360 equals, then times 2 equals, then times pi equals, and then times 22 divided by 2 would be 11, so times 11 equals. So that's 23.04. 23.04 centimeters. So if you got that answer, good job. Again, if you didn't get that answer, it's probably a calculator issue. You're not entering the numbers in the order that your calculator wants you to. All right, so we have just 8 more problems here. We're going to take the arc length stuff and we're going to do some different things. We're going to give you different numbers, and you're going to have to use that formula in different ways. That's just how it's done with math courses. They give you a formula, they're going to give you different numbers to plug in. So if K is the centers of the circles below, find the lengths of the following arcs. Round to the nearest hundredth as usual, and of course you must use the pi button in your calculator. Now this is asking for the measure of the central angle AKB. Okay, and it's giving us the arc length of AB, not the arc measure. It's giving us the arc length of AB, the length of arc AB, and it also gives us the radius. So we're going to plug in that information to find the central angle. So we're kind of going backwards here. So the arc length of, or the length of arc AB is equal to the central angle, which we don't know, over 360 times 2 pi r. So now let's plug in what we know and solve for what we don't know. We know the arc length. The length of arc AB is 8.28. We don't know the central angle. That's what we're looking for. And we know the radius is 5. They give us that. So now this is just an algebraic equation where we're looking for theta. Now there's a lot of different ways to do this algebraic equation. First of all, this is kind of just a one-step algebraic equation. But it doesn't really look like a one-step equation because the expressions are not really simplified. We can take 5 and multiply it by 2 and kind of simplify it that way. Then we get 10 pi. That makes things a lot easier. And probably the simplest way to do this is to go ahead and multiply both sides. And I'm going to show every step here because even though this is basic algebra, a lot of students have trouble with this. So first thing we're going to do is this is theta divided by 360. All right. So we want to get rid of that 360. So we're going to multiply by 360 because that's the opposite of division. If you want to get rid of that 360 and it's theta divided by 360, you have to multiply to get rid of to get rid of the division. So that cancels out the 360, and over here you're just left with theta times 10 pi. And then with your calculator you can do 8.28 times 360, and that gives us 2980. 2980.8. You don't really have to show all these steps if you don't have trouble with this arithmetic, but a lot of students are going to have trouble with this. So then you're going to divide both sides by 10 pi. So then we get 2980.8, and I'm not going to show the division, but that's 10 pi. So all we have to do is just calculate that number. So write 2,980.8 in your calculator, and then divided by 10 equals. So first we divided by 10, then you're going to divide by pi. Divided by pi equals. That's probably the easiest way to do it. The way that I just told you is probably the easiest way to enter it into your calculator. There are different ways that you can do it, but you should probably stick with that order. So 94.88. And this is degrees because it's a central angle. So that means that this angle has to be a little bit bigger than 90 degrees, a little bit bigger than the right angle, and you can see that that is. A right angle will be something like that, so that's a little bit bigger, so that makes sense. So actually I'm just going to show that step just to be absolutely clear what's happening here. Again, a lot of students may get lost with that math. So in that step we're dividing both sides by 10 pi. So we have 10 pi, 10 pi. I just want to be clear what's happening there. Alright, let's try another problem. We're looking for dk. Now dk is a radius, so in this case they give us an arc length, 6 meters, and we know that's an arc length because it has a unit of length, and we're given the central angle. So let's write down the formula. So the length of arc df is equal to the central angle over 360 times 2 pi times the radius. So that's just the same formula pretty much over here. We're just writing the different arc notation. And so the arc length is 6, and the central angle is 38. And now we don't know the radius. That's what we're looking for in this problem. So again, there's a lot of different ways you can do this, but probably the easiest way to do it is, like I said, multiply both sides by 360. Getting rid of the fraction is probably the most important thing to do. So times 360 times 360. The 360s, they cancel out on the right side of the equation, so you're left with 38 times 2 pi r equals 360 times 6. 360 times 6 is equal to 2,000. And you know what, I'm just going to leave it as 360 times 6 just to demonstrate the principle. And what I'm going to do is I'm going to kind of just regroup this stuff. I'm going to say 38 times 2 pi times r. So you can consider all this stuff to just be one big constant. And so we're going to divide by all that stuff. I know this seems kind of complicated, but it's really not. It's just basic arithmetic. So we're going to divide both sides by 38 times 2 pi. And then we get r is equal to, all we have to do in our calculator is 360 times 6. then divided by 38, then divided by 2, then divided by pi, if you want to separate those that way. You don't really have to show all of this stuff. If you can just do all those, if you can crunch those numbers in your calculator, that's all I really require. I don't require you to show every step here. So r is approximately equal to, we'll see. So 360 times 6 equals, and then divided by 38, because that's in the denominator, equals, and then divided by 2, because that's in the denominator, equals, and then divided by, push your pi button, and then equals. So we get 9.05. R is approximately equal to 9.05 meters. So in that problem we're looking for the radius. And we want to say that the radius is dk, so let's go ahead and plug in dk. And there you go. And I just realized in the last problem, measure of angle AKB, that's really what we were looking for down here. So I'll change that to measure of angle AKB. I would show all those changes of notation, but we don't really have room, as you can see. So on to 43. We'll do a couple more of these before you try some on your own. I know this. I know all this arithmetic seems kind of intimidating, but really it's just basic math. And again, you don't really have to show all this. All you have to do is just crunch those numbers algebraically, and it should take you about 10 seconds really. So we want the measure of arc GI. We want the measure of this arc. In order to find the measure of that arc, we have to find the measure of the central angle, but we don't have the measure of the central angle. So we have to use the information given. Now we know that the length of arc GI is equal to the central angle over 360 times 2 pi times the radius. We know the length of arc GI is 26.2. We don't know the central angle, that's what we're looking for, and then we can find the corresponding arc measure. And 2 pi, and then the radius is 10. First thing we should probably do is multiply both sides by 360. So times 360. And do that on both sides. And then we have 360 times 26.2, and you can see here why using dots is sometimes not the optimal situation, because we have a decimal. So I'm going to change those to parentheses. And that's equal to theta times 2 pi times 10. So now we're going to just consider all of this to be a constant and go ahead and divide both sides. And there's a lot of things we could combine. We could combine the 2 and the 10 there to make it 5, but I'm just trying to make this as simple as possible so you don't get lost with what we're doing here. So I want to get rid of that 2 pi times 10. So I'm going to divide. And then theta is going to be equal to whatever that stuff is. And now we can just, whoops, why did I write theta there? Equal to theta. Now we just get out the calculator, and we want to call this, we can call it the measure of angle GKI, I guess. The measure of angle GKI. is approximately equal to, get out our calculator, 360 times 26.2 equals divided by 2 equals divided by the pi button equals divided by 10 equals. So we have 150.11. So that is 150.11, and that is the central angle, so it's going to be in degrees. But that central angle is going to be equal to the corresponding arc measure, which is GI. So we can just change that to the measure of arc GI, and that is our final answer. So that's the measure of arc GI. So let's do one more of these problems before you try one on your own. Now we're looking for the circumference. Circumference is equal to 2 pi r. So this one's going to be fairly easy compared to the other ones. We're just looking for that expression 2 pi r. So we know, it tells us here that the arc length is 45 of JML. So that's this length here. So we know that length is 45 feet. And but we don't have the corresponding central angle. We're going to need that first. So the measure of arc JML is equal to 360 minus 41, and that's just going to be equal to 319, and 319 degrees. So now that's the central angle. So now we can say that the arc length of, and I keep forgetting to put arcs there, I'm sorry about that. Should be an arc on top of that thing. The measure of, or the length of arc JML is equal to 319 over 360 times 2 pi r. And we don't know the radius. Because we don't know the radius, we can't find the circumference. Now in this case, we're actually looking for this value here. All we have to do is solve for that value, and then we're going to be done. Actually, I probably should just plug in the theta first. That's the formula that we're using. So that arc length, we're told that arc length is 45, and the central angle we know is 319, and we're looking for actually 2 pi r. We're actually trying to solve for this, so this is going to be a little weird compared to the other problems. So what we do is we're going to go ahead and multiply both sides by 360 to get rid of that fraction. So times 360. It's probably best to use parentheses. And that's going to cancel out the 360. We get 319 times 2 pi r, and I'm going to keep 2 pi r grouped together because that's really what we're looking for. Notice it doesn't really matter where you place the parentheses as long as they're there. And so at this point, all we have to do is just divide by 319. And again, you don't have to show these steps. I know a lot of students are saying this is complicated. Well, not really. I mean, you don't have to show these steps. I'm just showing you so you're absolutely sure what's going on here, because if you're going to have trouble with these problems, it's going to be just entering the numbers into your calculator. So 2 pi r, which is what we're looking for, is equal to 360 times 45 divided by 319. So we can just get out the calculator. 360 times 45 equals, divided by 319 equals. and we get 50.78. So the circumference is approximately equal to 50.78. And that is going to be in feet. So be sure to write your units. All right, so those are just some practice problems for us. So now it's time for you to try. Go ahead and try number 45. You can take a screenshot of these if you need to. So try 45, and when you come back, we'll do it together. All right, we're back. So the length of arc AB is equal to the central angle over 360 times 2 pi r. That's the formula that we're going to use. We know the length of arc AB is 10. We don't know the central angle. And we know that the radius is 9. We're going to multiply both sides by 360. And like I said, it's probably best to just use parentheses. Usually can't go wrong with parentheses. Then we end up with 2 pi times 9 times theta, 360 times 10. I don't know why I'm changing parentheses there. It doesn't really matter. So now at this point, we're going to take that expression and divide everything by 2 pi times 9. And then we get theta is equal to 360 times 10 over 2 pi times 9. And theta is the same thing as the measure of angle AKB. Measure of angle AKB is approximately equal to whatever that stuff equals. So we can get out the calculator. 360 times 10 equals, divided by 2 equals, divided by pi equals, divided by 9 equals. And we get 63.66. 63.66 degrees is the measure of the central angle. That's the same thing as theta. But we want the measure of the arc AB, but that's equal to the measure of the central angle. So we can just say the measure of arc AB is equal to 63.66 degrees. So if you got that answer, good job. Go ahead and try number 46. Now 46, we're looking for diameter. So first you're going to need to find the radius, then you multiply the radius by 2 to find the diameter. Or you can just plug in d pi and just solve for d here. So go ahead and try number 45, and when you come back, we'll do it together. All right, we're back. So the arc length of dk, df, is equal to 136 over 360 times 2 pi r, and we don't know what r is, and actually I should probably just plug in, write the formula that we're using. So we know that the length of arc df is 8. We don't know theta. That's what we're, actually no, we do know theta. It's 136. And we don't know r. We're going to find r, then once we find r, we're going to multiply it by 2 to get the diameter. That's what we're looking for. So I'll just rewrite this. You don't have to rewrite. You don't have to show any of the work from here on, really. You can just plug it into your calculator, but just to make sure that you know what we're doing here, I'm going to show all this work. So I'm multiplying both sides by 360, and we end up with 136 times 2 pi r. Now we're looking for r, so I'm going to regroup these. Again, I'm doing all this just so you can see what's going on. You don't really need to do this. So I'm going to regroup all this. So you can see we just have a constant times r being the variable. So now I'm just going to divide everything by 136 times 2 pi. Whoops. And then we have r. R is equal to 360 times 8 divided by 136 times 2 pi. So now all we have to do is just crunch those numbers. And actually, we're going to do one more step. We're going to take all that stuff and multiply it by 2. Again, there's different ways to show this. So we took all that stuff there and we multiplied it by 2. Alright, so in the calculator, I'm going to do 360 times 8 equals, divided by 136 equals, divided by 2 equals, divided by the pi button equals, and then all that times 2 equals 6.74. So the diameter is approximately equal to 6.74. And what are our units? Meters. So if you got that answer, good job. If you didn't, that's okay. Now you see how to do the problem. So now we're going to try, you try 47, and when you come back, we'll do it together. All right, we're back. Now, not only do we not have this central arc, but we don't have the radius either. So let's talk about this. Can we find that central, that central angle? I said arc, I meant central angle. Can we find that? Well, yes, we can find that really easily. That's just whatever this angle is. It's just 360 minus 90 degrees because this is a 90-degree angle. Can we find the radius? And the answer to that is not really. We can't find it very easily. So this is kind of a different problem. The reason we can't find the radius is, well, first of all, they don't give us the radius, and secondly, they don't give us this arc length. So what we're going to do is we're going to have to use a different formula. Well, it's the same formula, but we're going to have to find a different length. We're going to have to find the length of arc JI. We're going to have to do that first, or we're going to have to use that. We're not going to find it. We already have it, but we're going to use it. So length of arc JI, that is 12, and then we'll plug in 90, because that's the corresponding central angle to that arc. And then we're going to use this information to find R. Once we find R, then we can find this other arc. So I'm going to rewrite that. I don't think we're going to have a lot of room here, so I may not be able to show every single step. 360, multiplying by 360, and then we get 360 times 12 equals 90 times 2 pi r. Now at this point, I'm going to, we'll just rewrite. I'm actually going to solve for 2 pi r rather than solve for the radius, because all we really need is just 2 pi r. and we can plug that into the expression. So this is a little bit weird. Just be aware of that. There's a lot of different ways to solve this. I think I may have given you one that's a little different than the ones we did before. So sorry about that if I confused you. It's a little bit different, not much different. So we divided both sides by 90. Now we have 2 pi r, so we can just plug that into the formula at this point. So now the formula is the length of arc JGI is equal to the central angle over 360 times 2 pi r, and we just found 2 pi r, so we can just plug that in. That's why I'm being sneaky there. Now we don't have the central angle yet, so I'm going to move this down. The central angle of that arc, GJI, this arc here, remember that's going to be 360 minus 90. So we have to do that first. So the measure of arc GJI is equal to 360 minus 90, which is 270, and now we can plug that in to that formula. So the arc length of GJI is equal to 270 over 360, and then we can plug in what we found for 2 pi r. So that's 360 times 12 over 90. And you may wonder, well, how come I don't just compute this? Why do I keep writing all these numbers? Well, because that just takes a lot of time and a lot of effort, and if you have to round off, that makes things even more complicated. So you probably just want to keep these numbers unless you're just going to crunch those in your calculator all at once. So 360 times 12 over 90, we'd plug that in, and so we just need to crunch those numbers, and whatever that ends up being, that's your answer. So we get 270 divided by 360 equals times 360 equals times 12 equals divided by 90 equals. There's a lot of different ways that you could do that. And we get the length of the arc is 36. And that's 36 feet. So if you got that answer, good job. And that makes sense because if this arc is 12, that should be a fourth of the whole arc length because 90 is a fourth. All right, so if you got that answer, good job. If you had a little trouble on that, that's okay. It's no big deal. But I want you to try number 48. And when you come back, we'll do it together. All right, so we're back. Let's try number 48. We're looking for the measure of angle AKL if the length of arc AML is 27.5. And again, I forgot to put an arc there. Sorry about that. So the length of this arc is 27.5. So we're going to use an equation for arc length using that arc that they actually give us. We have to use the information they give us. Length of arc AML is equal to the corresponding central angle, which would be this, over 360 times 2 pi r. So the unknown here is going to be theta. That's what we're looking for. We can first find this theta, and then once we find that theta, we can find the measure of angle AKL. So we know the length of arc AML is 27.5, so we can just plug that in. Theta we don't know, we're looking for that. And we know that the radius is 7. So again, you can just do this math in your calculator if you know how to do the algebra. But if you don't know, you can watch me do all these steps. And we're going to, of course, multiply both sides by 360. And let me make a little more room here. And that cancels out the 360, so we get theta times 2 pi times 7 equals whatever 360 times 27.5 is. And then, of course, we can rewrite that just to show the steps that we're doing. And divide both sides by 2 pi times 7. And we get theta is equal to 360 times 27.5 over 2 pi times 7. And again, I can do this a lot faster, and I can combine things a lot faster, but I'm purposely not doing that just to show you, what exactly is going on here. If I start skipping steps here, then it's going to get difficult if you get lost. All right, so we can then, again, if we find this theta value, that is this angle here, and we're going to use that to find this angle. So the angle that we're actually looking for, let's see what the best way to do this would be. I guess it would just be to calculate this first. So that angle is approximately equal to, let's get our calculator out, 360 times 27.5 equals, divided by 2 equals, divided by pi equals, and then divided by 7 equals 225, and we're going to carry out some extra decimals here. So 225.09056. And the reason I'm carrying out extra decimals is because we haven't gotten the answer yet. We're still going to have to use these to plug into other calculations. 0905 and 623. Just double checking that. All right, so now the actual angle we're looking for is a measure of angle AKL. So the measure of angle AKL is going to be equal to 360 minus all that stuff, 225 point, in fact, we can just say theta, so we don't have to plug in all those numbers. So the measure of angle AKL is approximately equal to and we can just take that number and we can just say minus 360, and that'll give us a negative number, but it doesn't really matter. We can just change it to positive because we know it's got to be positive, and then round to the nearest hundredth, and then we get 0.91 degrees. So if you keep that number in your calculator and just put minus 360, you'll get the negative number here, and you can just change it to positive. Or you can just write all that stuff down and then just plug it in, and your answer will be correct to within 1/100th of a degree. So if you got that answer, good job. If your answer is wrong, again, it's probably that you're not entering it into the calculator properly, or you may have not rounded off properly, or you may have rounded off too soon, so on and so forth. So that was the class today. Let's go ahead and take screenshots of all the work that we did. So you can use these for your notes or to study for tests. Screenshot number 1. Screenshot number 2. Screenshot number 3. Screenshot number 4. And screenshot number 5. And screenshot number 6. And screenshot number 7. And screenshot number 8. Screenshot number 9. Screenshot number 10. And now let's look at the homework. So here's screenshot number 1 of the homework. Screenshot number 2. Screenshot number 3. Screenshot number 4. And so be sure to get that homework done completely and correctly. Remember, if you don't do the homework, it's a 100% guarantee that you're going to learn absolutely nothing in the entire course. Be sure to show all your work if work is necessary. Remember, writing the answers doesn't tell you that you did the work. It doesn't show anybody that you did any work whatsoever. You have to show your work, and that will prove that you did something. Do the work completely correctly, neatly, and put it in order in your binder. And I'll look forward to seeing you in the next class.